Good morning, everyone. Myself, J. Anusha, working as lecturer in physics in the department general section, working at SS Government Polytechnic, Zahirabad. And for first year, second sem students, the subject I am dealing with is applied physics with the subject code 18 common 203F. And the topic what we are discussing here is the fifth chapter of our syllabus, electricity and measuring instruments. Now from this chapter, in today's class, we are going to study about conversion of a galvanometer into an ammeter. So to learn this, we are using a small PowerPoint presentation here with the help of pictures if needed. We'll learn how we can convert a galvanometer into an ammeter. So the main objective of today's class is, on completion of this period, you would be able to understand the conversion of a galvanometer into an ammeter. So before moving on to today's class, let us recall what we studied in last period. We studied about the construction and working of moving coil galvanometer. So let us see how we can convert a galvanometer into an ammeter. An ammeter is an instrument which is used to measure the large currents passing through a circuit. So for this purpose, it is put in series with the circuit in which the current is to be measured. So what we can understand here is, when it is put in series with the circuit, nothing but an ammeter. When it is in series with the circuit, we can measure current. Now for accurate measurement, an ammeter must have the following two properties. So it must have a very small resistance. In an ideal case, it should be 0, and a very large current carrying capacity. Since galvanometer is a very sensitive instrument, therefore it cannot measure heavy currents. In order to convert a galvanometer into an ammeter, a very low resistance known as shunt, this resistance is connected in parallel to galvanometer. The value of shunt is so adjusted that most of the current pass through the shunt. In this way, a galvanometer is converted into an ammeter and it can measure heavy currents. So here we can see how a galvanometer is converted into an ammeter. So here we can see galvanometer which is connected with shunt in parallel connection. Let G be the resistance of the galvanometer and I be the maximum current measured by the ammeter. And Ig is the maximum current that can be passed through the galvanometer. Then I minus Ig. Here you can see very clearly that the current which is going to pass through the shunt resistance is I minus Ig. Since G and S, galvanometer and shunt, are in parallel combination, the voltage drop across shunt is equal to the voltage drop across galvanometer. So that is, voltage drop is nothing but resistance into current. So I minus Ig into S is equals to Ig into G. Now using this, the shunt resistance S is given by Ig by I minus Ig into G. So this is the value of shunt which is connected in parallel to the galvanometer, and this connection is converted into an ammeter of range 0 to I amperes. The effective resistance Ra of the ammeter is given by 1 by Ra is equals to 1 by G plus 1 by S. So when simplifying this, we got the effective resistance Ra as Gs by G plus S. So the resistance of ammeter is smaller than shunt resistor. Since shunt resistance is low, the resistance of ammeter Ra is very low, and when it is connected in series in the circuits, it will not affect the current passing through the circuit. An ammeter is a combination of galvanometer and shunt with the low resistance connected in parallel. So let us summarize what we discussed in today's class, that we have seen conversion of a galvanometer into an ammeter. Now let us see how much we have understood from this topic. Electric instrument which is used to measure large currents in circuits is ammeter, voltmeter, ohm meter or odometer. It is ammeter. How is a galvanometer converted into an ammeter? By connecting a high resistance shunt in parallel to the galvanometer, or low resistance shunt in parallel to the galvanometer, or high resistance shunt in series, or low resistance shunt in series with the galvanometer. It is low resistance shunt in parallel to the galvanometer. So an ammeter should have infinite, very large or very low, or none of the above resistance. So it is very low resistance. So the frequently asked questions from this topic are: explain the conversion of galvanometer into an ammeter. So this is about today's class. Thank you. శబ్ద కాలుష్యాన్ని
Conversion of a galvanometer into an ammeter. A galvanometer is a device used to detect the flow of current in an electrical circuit. Even though the deflection is directly proportional to the current, the galvanometer scale is not marked in ampere. Being a very sensitive instrument, a large current cannot be passed through the galvanometer as it may damage the coil. However, a galvanometer is converted into an ammeter by connecting a low resistance in parallel with it. As a result, when large current flows in a circuit, only a small fraction of the current passes through the galvanometer, and the remaining larger portion of the current passes through the low resistance. The low resistance connected in parallel with the galvanometer is called shunt resistance. The scale is marked in ampere. The value of shunt resistance depends on the fraction of the total current required to be passed through the galvanometer. Let Ig be the maximum current that can pass through the galvanometer. The current Ig will give full-scale deflection in the galvanometer. Galvanometer resistance is equal to G. Shunt resistance is equal to S. Current in the circuit is equal to I. Current through the shunt resistance is equal to Is is equal to I minus Ig. Since the galvanometer and shunt resistance are parallel, potential is common. Ig into G is equal to I minus Ig into S. S is equal to G into Ig divided by I minus Ig. Resistance is very small because Ig is only a fraction of I. The effective resistance of the ammeter Ra is G in parallel with S. 1 by Ra is equal to 1 by G plus 1 by S. Ra is equal to Gs by G plus S. Ra is very low, and this explains why an ammeter should be connected in series. When connected in series, the ammeter does not appreciably change the resistance and current in the circuit. Hence, an ideal ammeter is one which has zero resistance.
Conversion of a galvanometer into an ammeter. At the end of this to convert a galvanometer into an ammeter of desired range and also verify the same. To conduct the experiment, you will need a table model galvanometer, a voltmeter, a battery eliminator, 2 resistance decade boxes, 2 one-way keys, a rheostat, a screw gauge, a meter scale, an ammeter of given range, and connecting wires. A galvanometer is an instrument which is used to detect the flow of electric current and its direction in a circuit. An ammeter is an instrument which is used to measure the strength of electric current through a circuit. It is a modified form of galvanometer. An ammeter is always connected in series in a circuit. To convert a galvanometer into an ammeter, a very low resistance known as shunt is connected in parallel to the galvanometer. The value of shunt is so chosen that most of the current passes through the shunt. This prevents large current from flowing through the galvanometer, which may damage it. If Ig is the current required to produce full-scale deflection in the galvanometer, the remaining current flows through the shunt resistance S. Since the galvanometer and the shunt are parallel to each other, we can write Ig times G is equal to I minus Ig times S, where G is the galvanometer resistance and I is the maximum current that is to be read by the converted galvanometer. Thus, the value of shunt resistance for the conversion of galvanometer into ammeter can be calculated with the formula S is equal to Ig times G divided by I minus Ig, where I is the range of the converted galvanometer. Let's first calculate the value of shunt resistance.